Hey guys, this is Professor Janacek. I just want to go over some examples working with limits. All right, so the first one is the limit as x approaches 1 of the square root of x minus 1 over x minus 1. Now, looking at this, you might think, well, we can simply evaluate all of the x's for 1 and see what we get. Well, there's a problem here. You'll notice that this denominator gives us 0. You'll notice I am not writing down something like 0 over 0 because that's not a number. This is something I can't write down. So it turns out not going to do that, definitely, but also this is a dead end. It gives me division by 0, which causes a problem. So what do? Well, I notice that I have a radical in the numerator. And anytime you have radicals and you want to kind of do something with them, you can always try to rationalize. Because the radical is in the numerator, I will rationalize the numerator. However, if the radical had been in the denominator, then I'd be rationalizing the denominator instead. Let's see, what does that mean? Well, to rationalize, in this situation, since my numerator is a binomial, I'm going to multiply by the conjugate of that numerator, which is the square root of x plus 1. Of course, I have to multiply that in both the numerator and the denominator to make this all work out. So let's see, what do we get? In the numerator, I am going to multiply all this out and combine like terms. Take your time with this. If you need to multiply, and combine like terms, take a moment for that if you need. You should end up with x minus 1 in the numerator. In the denominator, actually, I see what's about to happen here. You might as well. I'm going to go ahead and leave it in that form because what happens is that x minus 1 reduces. Oh, how nice is that? So we end up with the limit as x approaches 1 of 1 over the square root of x plus 1. Now if we try that little technique of evaluating all the x values, looks like we end up with 1/2. Much better. No division by 0 there. Fantastic. On to the next one. Let's take the limit as x approaches 5 of x squared minus 7x plus 10 all over x minus 5. Well, in this case, again, if I were to just evaluate this rational expression, we would end up again with 0 in the denominator. Can't have that. So what do? This one you might actually have already guessed. In this case, it looks like I might be able to factor. And that's exactly what I'm going to try. So, the numerator factors to x minus 5 times x minus 2. The denominator does not factor. I'll leave it as is. However, that's okay. I notice those x minus 5s reduce. Oh, isn't this lovely? We end up with the limit as x approaches 5 of x minus 2. Because that's polynomial, I can simply replace that x with a 5. We get 5 minus 2, which is 3. Oh, wasn't that one nice? All right, we've got one more. In this case, again, if we were to simply evaluate all of those w's with a 1, we end up with 0 in the denominator twice. Again, not allowed to have that. So instead, in this case, what I'm going to do is I'm going to combine the expressions. It's sort of like adding and subtracting fractions. You'll have to get a common denominator. So let's see. First thing, I'm going to go ahead and factor this first denominator just so I can see what it's made of. And while I'm at it, I'm going to change this to an addition problem. Add the opposite, if you will, just so I don't lose that negative. Now I see that I can get a common denominator. Looks like w times w minus 1 will work. The first fraction stays as it is. The second fraction, or rational expression, I need to multiply that by a w. And so putting these together, we have in the denominator w times w minus 1, and then in the numerator 1 minus w. Now, nothing reduces like it is. However, I see that if I factor out a -1 in the numerator, now I'm not multiplying by -1. This is, I'm going to factor out a -1. Right, that's what's going on here. Notice what happens when I factor out a -1 from that numerator. I would end up with -1 plus w, which I could turn around and write it as w minus 1. Again, if you don't agree with that numerator, you could go ahead and distribute that out and verify that it does indeed give you 1 minus w. So just take your time with that. But now, oh, how great is this? We can reduce those w minus 1s, and we end up with the limit as w goes to 1 of -1 over w. Now I can evaluate this without much problem, and we end up with -1. Now, all of these techniques really included a lot of algebra, so just remember that algebra equals fun. I hope. Enjoy!